Hello. Today we are going to multiply a polynomial by a monomial. So a polynomial means, again, many terms. So it can have any number of terms. And we're going to multiply it by a monomial, meaning it has one term. So in order to do this, we are going to go ahead and distribute the monomial to the polynomial. So for this first one here, we're going to take 5a squared, and we're going to multiply it by each term that's in the parentheses. So when we multiply this, we're going to take the numbers out in front and we're going to go ahead and multiply those. And then for the a's, because we are multiplying, our exponents are going to change. So we're going to do 2 plus 2 for our exponents. So when multiplying, multiply the numbers out in front and you're adding your exponents together. So now we're going to distribute 5a squared to the 2a. So we're going to do 5 times 2 to get 10, and a squared times a is a to the third power. And then we're going to do 5a squared times negative 7, and that's going to give us negative 35. And then for the a squared, we just leave that as a squared because there's nothing to multiply it by. So this is already in standard form naturally because we have the fourth, third, and then second degree, and there's no terms that we can combine. So let's try another one here. We're going to go ahead and distribute negative 6d to the third to each term here. So we're going to do negative 6 times 3 to get negative 18. For your d's, you're multiplying 3d's by 4d's to get 7d's in total. For the next one, we're doing negative 6 times negative 2, and a negative times a negative is a positive, so that becomes plus 12. And we have 3d's, and 3 more makes 6 in total. We're doing negative 6d cubed times negative d. So the negative 6 times the negative 1 becomes a positive 6. We have 3d's plus 1 more makes 4 in total. And then our last one here, negative 6d to the third times 9 would become a negative 54, and then d to the third power. So this is already in standard form because it has every degree in decreasing order. So now what we're going to do is that same idea, but we're going to combine it with combining like terms. So let's do this first one. We're going to multiply everything here by 3. So that's going to give us a 15x squared, a 6x, and a minus 12. This next one here, we're going to multiply everything. Careful with this one because we're going to multiply it by negative x. So we're doing negative x times 7x squared. That becomes a negative 7x to the third power. So then we're going to distribute this negative x to the 2x. That's going to become negative 2x to the second. And then this last one, negative x times negative 3. The negative times the negative makes it a plus. And then we have just the 3 and the x because those are just, we're multiplying together and we can't combine them really. So it's just plus 3x. So now we have multiplied everything through a distributive property. So it's just an issue of combining like terms and writing it in standard form. So we have this negative 7x to the third first. I have x squared would come next, so 15 minus 2 becomes 13. Here's where we leave it as x squared because we are adding. So remember, when we're adding, we add the coefficients and leave the variables alone. Then we have a positive 6x and a positive 3x. So overall, there are 9x. And then the last one there is minus 12. There's nothing to combine with that. So let's try another one. We're going to distribute. We're going to do 15 times 10 to get 150. I have 3 y's, and this t is getting multiplied by 5 more to get 6 in total. Then 15 times 5 is 75, y squared, and I have 1t times another, which means there's 2 in total. So for this next part here, I'm going to distribute the negative 2y to each term here. So it's going to become negative 2. And then I have 2y's, which is y squared, and t squared. And then we're going to do negative 2 times the 4 to get negative 8. And there's 3 y's in total. So now it's an issue of combining like terms. I see I have y squared and t squared twice in this problem. So this first term of 150 y to the third t to the sixth goes first because it has a degree of 9. The next term would be these two combined together. I'm going to do the 75 minus 2 to get 73 y squared t squared minus 8y to the third at the end. So we can distribute monomials to polynomials and then even add them together. So there are a couple more examples here. What I would like you to do is try example 5. So pause the video and you try it, and then when you're done trying it, come back to the video. Okay, so now that you've had a chance to try it, this first one here should be 24y to the third minus 54y squared minus 42y. This next one, you needed a couple distributions here. You get 6t squared minus 12t minus 45 plus 30t squared plus 12t. So that's the first phase, is to distribute. Now we're going to combine like terms to get 36t squared. The t's actually cancel each other out, so we just have minus 45 at the end. Okay, so now that we know this distribution properties, what we can do is we can take each equation here, and using the distributive property, we can do exactly what we had done, but we can now solve equations. So looking at this, we're going to go ahead, and anytime there's a coefficient, we're going to distribute that. So we get 2x squared plus 8x plus 7. On the left-hand side, and then on the right-hand side, this x plus 8 has nothing out in front to distribute, so I'm just going to rewrite that. But this x plus 1 needs to have the 2x distributed to it. So it's 2x squared plus 2x. And then we still bring down this plus 12. You notice it was after the parentheses, so it is not actually getting the 2x distributed to it. Then what we're going to do is we're going to treat this as like two sides here. So we're going to leave everything on the left-hand side alone, only because there's no like terms or anything. Everything is already combined. If there were things to combine, you would actually combine them now. On the right-hand side, we're going to combine like terms. So the 2x squared goes out in front. We have 1x and 2 more, so 3x in total. And then we have 8 and 12 to give us 20. So now normally what we would do is we would get all of the variables on one side. So I'm going to go ahead and subtract my x squared to the other side. Now when I do that, it cancels out on the right-hand side, but interestingly enough, it also cancels out on the left-hand side. And that's good because we don't know how to solve an x squared as of right now. So instead we have 8x plus 7 equals 3x plus 20. And we can now solve by getting the x's on one side. So we're going to get 5x plus 7 equals 20. So we're going to subtract the 7 over. We get 5x equals 13. And we divide to get x equals 13 over 5. You might not end up with nice answers, but that's okay. So then for this next one, we're going to do the same idea. We're going to use the distributive property anywhere we see those parentheses. So we get 6t squared minus 12t minus 45. Now we're going to distribute the 6t here to get 30t squared plus 12t. And we're going to distribute the 9 here to get 36t squared plus 9t. Now we're going to combine like terms. So I see t squared and t squared. Those are going to give us 36t squared. I see a negative 12t and a positive 12t. So those actually cancel each other out. And then I just have my minus 45 left. On the right-hand side, there's nothing to combine because there are no like terms. So we're going to move the t squared over to one side, and in doing so, it actually cancels out the t squared term. So we get negative 45 equals 9t. When we divide there, we end up getting t equals negative 5. Okay, so for our last one, we're going to do an application problem. We are making triangular bandanas for the dogs and cats in Serena's Pet Club. The base of the bandana is the length of the collar with 4 inches added to each end. So since we don't know the length of the collar, what I'm going to do is I'm going to call that C. So the length here, the base, is going to be the length of the collar with 4 inches added to each end, which means if I'm adding 4 on each side, I'm actually adding 8 inches in total. So whatever the collar is, if I add 8 to that, that would be the length of the base of the bandana. Now this other one, the height, is going to be half of the collar length. So if I draw in my height here should be 1/2 of whatever the length of the collar is. So if we take a look at A, this diagram should help us solve this. So if Serena's dog has a collar length of 12 inches, how much fabric does she need in square inches? So if it's asking us how much fabric she needs, we are looking for the area of this. So for this one, what we're going to do is we're going to find the area of the triangle by doing 1/2 base times height. So if you want, you can actually plug in C plus 8 and 1/2 C in for your base and your height and simplify. Or what we can do is we can say if the collar is 12 inches, that means my base here, if I do 12 plus 8, I would get 20. And my height here, if I plug in 1/2 of 8, oh, nope, let's do 1/2 of 12, I would get 6. So to find the area of what I need, I'm going to do 1/2 of 20 times 6. Now half of 20 is 10, and 10 times 6 would be 60. So this would be 60 square inches. For part B, now we want a cat. The cat has a 6-inch collar. So in this problem, the collar here would be 6. So we're going to do 6 plus 8. And so when we do our area, it's going to be 1/2 of the base, which if we plug in 6 plus 8, we get 14, times the height. And if we do half of 6, we end up with a height of 3. So half of 14 is 7, and 7 times 3 is going to be 21 inches squared. So you also could have done this problem by multiplying C plus 8 and 1/2 of C. But again, you can just kind of plug in the values and then use numbers instead as well. So thank you very much for listening. I hope it helped.